Hello, good morning, everyone. We are very welcome to the CETA BIM gathering, particularly to this session on the cultural shift in attitude towards BIM. My name is Ken Thomas. I'm the head of school here in engineering in Waterford Institute of Technology. But I'm also a director and a co-founder of CETA. And CETA is 20 years in existence and been a big part of the journey that we've had in this country, in Ireland, in our adoption of the relevant technologies. So very exciting journey and a very exciting gathering again today. We've got 3 speakers in our session here this morning, and we will go through the 3 speakers in sequence and then hold questions and answers for the end, if that's okay with everybody. There is a facility in the chat box to ask questions, and we will be able to hopefully have time at the end to ask those to the 3 speakers and to get some answers. So delighted to be here again today, and hopefully you're enjoying the event so far. I'm going to introduce our first speaker now, if that's okay with everybody. Our first speaker today is Conor Shaw from UCD. Conor is going to talk to us on the ongoing cloud BIM research activities at UCD, exploring semantic web-based approaches to support FM and BAS processes. So Conor, over to you.
Thanks a lot, Ken. Can you hear me okay? Good stuff. Thanks for joining everybody to the session. My name's Conor Shaw. I'm a researcher at University College Dublin, and I'm going to tell you today about what we're doing at UCD in the area of BIM research, particularly cloud BIM research. I'm going to introduce a topic that Claire Penny, you might have noticed in the last session, mentioned was ontologies and knowledge graphs. So I'm going to introduce the term semantic web, and what I'd like to just get out of today, if anybody's interested to continue the discussion or have any further questions, it's quite a handful to explain semantic web in 10 minutes, so I'll be brushing lightly over it, but happy to continue the discussion. So I'm part of a larger Marie Curie research project. It's called the Cloud BIM Initiative. We're 14 researchers from across the world, and we're now based at mainly European institutions, academic and industry. And a big part of what we're doing is we have about 9 months in place secondments with different industry partners during our time. And what we're looking into is futurizing about what the cloud can enable in new building information paradigms. We're headed by the prominent Raphael Sachs on this research project. And I'll give the links out on a PDF later on, and you can check out our website there. So on the top level, what we're doing in UCD under the direction of Dr. James O'Donnell in the past has been looking at BIM for simulation, energy performance, thermal comfort analysis. And where we get to today is having 2 PhDs working on data fusion using semantic web technology. So I'm speaking on behalf of my colleague Flavia, who's based in Cartif Technology Center in Valladolid, Spain. And she's looking at the integration of BIM and building automation systems, and myself looking more broadly at facilities management and data fusion for facilities management use cases. So to answer 2 questions, first, why do we focus on the operational phase? This is really the motivation for both of us is coming from the need to reduce anthropogenic carbon emissions, and a look at the operational phase of a building's life cycle as being the predominant emitter of that. So that's in a nutshell why we look at operations phase. And the second question answer is, what is semantic web? Okay, so in a nutshell, the current web that we use today is really targeted at human consumption. So you'll be used to clicking on a URL and linking to a document. And this is really human consumption. You need to read through it. And what the semantic web is basically an enhancement of what we have the current web, but making the information more machine understandable. So Claire Penny mentioned earlier about ontologies, about structured knowledge. and classifications. This is the types of topics that we're talking about in semantic web technologies. So Claire mentioned ontologies. So one of the more powerful parts of the semantic web is this structuring of domain knowledge into ontologies. So for example, we may have a structured knowledge from two different disciplines. And what we can do using semantic web technologies is align on common terminology, common understanding. So for example, these two domains might have a common word, say wall, and we might be able to align their knowledge bases on that term. And another key part of semantic web is that we're starting to make data open and available on the web and over the web. And what you see there on the right is the open web of knowledge. So this is about 1,400 structured ontologies from different science and technology domains, which are made openly available on the web. And using this open network, we're able to reason across different domains and give greater context to our data. So some of the kind of key value propositions, I suppose, of semantic web are that we're moving away from proprietary formats. We're moving towards open data, and we're keeping domain data in source. So we're getting away from file exchanges, and that's a really key part. We all know, anyone who's been working with BIM data for a long time will know data exchanges are really complicated, and scalability issues when we talk about things like model view definitions and implementations. It's very software development heavy. So we're getting away from file exchanges and getting more towards access. And once we have access, we can query across these various databases. Okay, so a kind of more tangible use case for the construction industry. So we're familiar with static BIM data, architects' models, engineers' models. But when we get to an operations phase, we're really needing data types that aren't suited to be hosted in the current BIM data format. So we're needing to link IoT data sets and time series data sets. And this is a demonstrator by Rasmussen in a recent PhD, where they're looking at using hosting this in the cloud using the open RDF data format to create an operations model which can be queried in very great granularity. So I encourage you to follow that link if that's interesting to you. So myself and Flavia are looking at semantic web use in the operations phase, and I'll tell you quickly about each of our research areas. So Flavia is looking at the integration of BIM and BAS, and what she's looking at is a use case of demand side management. So demand side management is basically, as we move to a renewable grid, we have a much greater mismatch between supply and demand, and demand side management strategies are various strategies to balance this, using, for example, having smart balancing. So having the context that is provided by BIM and BAS data can improve that demand side management usability, and she's looking into using semantic web technologies to do that data fusion. From my own side, I'm looking very broadly at facilities management and looking at various use cases that facilities managers need from their data. So I've been using BIM heavily for understanding buildings, for capturing the data in buildings and understanding how they work, and then planning how they can be built better, more efficiently. But as we've seen earlier, that's static BIM gets us only so far, and when we get into the operation phase, we need dynamic data. So my hypothesis, basically what I'm interested in, is looking at how giving greater access to FM practitioners can democratize FM processes. As we know now, there's quite a high technical threshold and access to participate in BIM workflows. And what I've been doing so far is just looking at some of the main challenges faced by FM practitioners in a first publication, and in a publication now under review, I'm looking at the use of semantic web technologies actually in FM cases to date, and actually there's quite a large uptake. And I suppose a couple of technical issues are still to be figured out. There's no question, but I guess the value proposition of using semantic web in this area is that because you may say that we do have suppliers who can give digital twin platform solutions. I agree with you, but the cost and the implementation is very it's very high. And not scalable to a much wider audience. So I think that's the value proposition of semantic web use, is that it maybe brings down the participate threshold. But again, to bring that threshold down, we need much greater abstraction from programming languages, which there is at the moment. And I'd end on just directing you to a very interesting use case of semantic web in industry. So the Schiphol group are maybe the airport in Amsterdam are a pure client, and they're outsourcing all their FM activities in the airport. And there's a very interesting talk from the Building Smart Web Summit this year, where they're discussing the use of open data and linked data and semantic web use. And we were talking about cultural shift. I think what they're looking at is really that it's changing the culture of how data is managed, how it's accessed. And I suppose the key takeaway here is that this semantic web topic is not just in academic tinkering now. It really is being used in industry, and there are examples there. So you can follow a few links to pieces of research I cited inside here, and if you're interested to chat further about it or learn a bit more, I really very briefly touched on some of these topics, but we see it, and a lot of us see it as a real possibility for a paradigm shift. So the same way I felt about BIM when I first saw it 12 years ago, I saw this real paradigm shift. I really believe that this is capable of doing the same thing. So I'd be happy to discuss more, and you can get in touch with Flavia or myself. So thanks for that, and happy to take questions at the end.
Okay, Conor, thank you so much for that. Very good presentation. And I have lots of questions, and I'm sure there's lots of questions out there as well for you. So hopefully we'll get some of those later on. Things like moving from static to dynamic, I picked up on those ideas, and then this idea of the digital twin, which is a lot of talk about dynamic digital twins around the world at the moment, but how we can get there. I think your work and your project sounds like is on that journey really, and I love the fact you got real examples as well, which is the Schiphol example and so on. So hopefully at the end of the session, Conor, we'll come back and have a couple of questions for you, if that's okay.
Sounds great, thanks.
Thank you. And we'll now move on to our next presenter, who's Zulkefly Bakar from MCA Architects. Zulkefly is going to talk about a proposal to harmonize BIM and IoT data silos using blockchain applications. Over to you, Zulkefly.
Yeah, thank you, Ken. Yeah, thank you, everyone. And thank you very much to Sita for this opportunity. And I'm very happy to be here today. And okay, let me introduce actually myself. I'm Zulkefly. I'm currently taking a role as a BIM coordinator at MCA Architects. And I'm also currently a student and study artificial intelligence and machine learning at National College of Ireland. And today I'll be presenting my paper titled "A Proposal to Harmonize BIM and IoT Data Silos Using Blockchain Application" that I do during my final year of MSc in Applied BIM and Management at TU Dublin that I finished last year. And first of all, allow me to thank you, Dr. Malaki Matthews, for as the co-author for this work, and also the supervisor. Thank you for his valuable knowledge, in particular blockchain field, and support and courage for me to do this presentation today. So a bit disclaimer before I start is all views in these presentations belong solely to the author. and not necessarily to other employers, organization, or individuals. So without further ado, in today's agenda, firstly, I want to give an audience an overview of the work, the research background. The first one, the research background covering problem, statement, and objective. Secondly, I want to discuss about a challenge of BIM and IoT data integration. And next, I will be briefly guide audience about what is blockchain and the key components or application, and finally demonstrate with the proof of concept to demonstrate the blockchain capabilities. Okay, my research background, starting out with the problem statement. As we know, the integration of BIM and IoT in digital and physical world can provide a significant end-to-end benefit. So, but however, data silos, as we know, have impacted the integration process. This is caused by, for example, a disconnected system, like a centralized unintegrated database system across two or multiple repo. And next one, maybe because the industry running on the file-based system still, so it creates a data reliability and interoperability issues within the participants. And thirdly, and most important, is the security issues that I'll be covering. The security issues, current system were vulnerable to attacks and theft and malicious activities. So it's really hard to actually connect between BIM IoT due to these issues. So my objective is really aim to build a relationship between the shared environment within the BIM and IoT. And I try to use, as you can see in the anatomy of technology, I'm trying to use blockchain actually to secure the BIM and IoT environment by building a trust, allow data to be shared while providing reliability, security, and transparency, privacy for data owners, and maintain control their own built assets and access. And thirdly, I'm trying to creating a value, trying to leverage end-to-end benefit information provided by harmonizing data silos between the environment. So first, when we discuss about BIM, then the first place that we look is a common data environment, or the CDE. As part of digital evolution in the construction industry, the BIM or the CDE itself aims to change the dynamics and behavior of the traditional work process and how we share information. So the CDE constantly evolve and drive the AEC industry to the data-driven model. But the one thing, the question really, the issues of the current state of the CDE, does CDE actually change the way we communicate and how data is governed within the platform, the shared environment? So let's dive into the challenges, the BIM management challenges. If we look closely, the CDE composed of many parts, and most of them are unstructured and unconnected. Every day we're dealing with and receive many unstructured data. This includes emails, word processing, multimedia, etc., etc. And from many projects which are inefficient for the machine to digest, result the data sitting in unconnected silos, which has raising trust issues within the participants. And not many of the parties involved within the environment want to take their responsibility to the shared information due to the lack of clarity regarding roles and interoperability in the process. So this contributes to data redundancy and then easy to manipulate because of lack of control and such. The information received is also resolve intensive. It's actually very difficult for me. Day-to-day job as BIM coordinator is very difficult to create an audit table or access log. And it's also impossible to verify as a data grow. So next, we discuss on the IoT challenges. In general, IoT is a system that employs interconnected smart devices like your smartphone or TV to transfer data using the internet. So IoT data, on the other hand, are very noisy because of the different types that transmitted from the various types of device and domains. And also IoT facing the vendor also now incentive to share the market and with the competitor. This will create a data lock in silos issues and also cause interoperability issues, not only within the environment, but also outside the internet. For example, when you're trying to integrate with the BIM, for example. So that's the thing that we need to rethink with the integration. We need to actually consider approach that can establish the end-to-end collaboration via a single source of truth that can enable understanding, analysis, and informed decision making. And we're trying to transform unstructured data to actually a more structured data. So during my literature reviews, I have identified a couple of technology solutions, and one of them is blockchain technology. Blockchain technology is, as we can maybe heard, the image as a disruptive innovation to democratic data sharing. Maybe this is too broad in terms of definition, but let's see how the blockchain, what is the blockchain, how it actually works. This is just a brief example. So first of all, blockchain is actually not cryptocurrency. So it's actually not a blockchain, not a Bitcoin. So but no doubt the cryptocurrencies like the Bitcoin itself or the Ethereum has changed how we see money, perceive value, and ownership. For example, NFT, non-fungible token, how we can utilize for ownership, verify ownership. So blockchain is actually essentially a digital ledger to record a transaction. So actually, what is different between the traditional ledger and the blockchain? Firstly, blockchain using a hash function to make a transition difficult to tamper, and secondly is distributed across a network of computers using a P2P network to share ledger. That means that it has a decentralized capabilities and distribute power away from central authority. The data stored in the blockchain is broadcast in the network, so anyone with a key to able to permit and verify the transition in the blockchain ledger. So these are the main components of the blockchain application. As we discussed earlier, the distributed ledger in the design to record transaction across the network of computer use a consensus mechanism. Actually, consensus mechanism is a agreement mechanism used by the network of computer to verify information in the blocks. The common type used blockchain technology is consensus is proof of work, but of course the proof of work use a lot of energy, but then again there's 100 or more consensus that can use to actually use a zero energy. It really depends on how we design the work use case and how we use the technology. And last and most important component of blockchain is the smart contract. Smart contract, basically a segment of code, is a trigger when a certain event is activated. So it's basically enable automation of data flow of information. Okay, so I just jumped through a proof of concept that I created. I choose a very common use case. This, for example, I use for health and safety record. I try to demonstrate how to collect telemetry information and link the data in the distributed ledger and BIM model. So for the solution architecture, I'm using the Microsoft Azure for building and managing IoT data and also managing a smart contract. So interconnected between BIM data and Azure platform is achieved within via Forge API. Autodesk Forge API. So I will jump through into the process. The first step I'm taking in creating the proof of concept is install a MX chip IoT dev kit with the temperature and humidity sensors to collect to provide a telemetry data for the BIM. So the next one, the BIM model will initiate to the web viewer to host the metadata from the digital assets. BIM model were altered in the Revit Autodesk Revit and used as a virtual twin. So the data from the IoT sensors then link into the digital model in the web by using a call function coded in JavaScript. So this brings all the 3D information and IoT application into the Azure IoT Hub. So the next, this is most important. This is where blockchain take a role with a web app setup and a smart contract then can be deployed. A smart contract is actually a piece of code that can automate a transition between the environment. So this contract enforces a specific function according to a parameter that are specified in the IoT device. So the humidity and temperature rules measurement are specified by the participants and deployed to the workbench, a blockchain workbench. The smart contract application was built to secure this transaction between the multiple counterparties at any given time. So the next, the function of logic apps is actually to automate and trigger the process. And upon finding a new message, the logic app is actually create a message and ingest the telemetry into the smart contract. Then this contract collects telemetry data, and then upon receiving and evaluating temperature, humidity data against agreed upon acceptable range. If the IoT device identifies that the telemetry out of acceptable range, the contract will shift into out of compliance and appropriate action can be carried out. So the last step is really the basic process, evaluating temperature data against is really benefit the user. This information can also be viewed and queried at any point in the blockchain explorer. So my findings with the proof of concept is really the smart contract records an agreement relationship between BIM and IoT. And the next one, blockchain consensus allow appropriate access to verified data. Then this can create a trust and distribute across multiple parties involved without this point of failure. And the third one is data transacted within the environments are validated and recorded in distributed ledger. This is the valuable assets for making a more accurate prediction and decision making. So, and after all, BIM and IoT is about connection, perhaps by emphasizing blockchain potential role in promoting better collaboration and integration between BIM and IoT environment would reveal the real benefit of leverage this technology. Harmonizing data silos, encourage AEC industry to actually develop a more collaborative, flexible in a creative environment. And originality and value of building life cycle maybe can be redefined. Yeah. Thank you.
Okay, thank you, Zulkefly. Very interesting, and lots of big topics included in your conversation there. When we set up CETA 20 years ago, we were talking about data silos, and we're still talking about data silos. Obviously, technologies move on, but the interplay between technologies, people, and processes continue. And we probably have more data now to unsilo or desilo. I like the idea of we're dovetailed with Conor's previous presentation on that dynamic link and predictive analysis and so on. So I'm sure we'll have some questions maybe at the end, if that's okay, if you can wait until then. And we'll move on to the next speaker. So our third speaker today, I'm delighted to say, is Michael Martin from the HSE Estates. And Michael is going to talk to us today on, we'll answer a question: can the implementation of building information modeling, digital construction, improve delivery of capital projects for the health service in association with the development of the new National Estates Information System. So very interesting and an important topic for the country, but also internationally as well. So over to you, Michael.
Thanks, Ken. And the subject is a bit meaty in the title, but we'll get straight into it. So as Ken said, I'm involved in HSE estates. I've been there for about 20 years and 10 years experience prior to that in the construction industry. So I've recently completed a degree in BIM in TU Dublin, and this is the paper as part of that degree. So just as a background, the HSE Capital and Estates was established in 2005. There were previously 11 in the Independent Health Board before that. At the minute, there are 10 regional offices around the country responsible for about 4,000 property blocks, ranging from acute hospitals to offices to warehouses. We have an annual capital budget in the region of about 1 billion this year, and the reinstatement value of the state is around 14 billion. There is a protocol in place for the delivery of capital projects, which adds a bit of structure. But we have identified a need to integrate business processes and provide a single sort of information. That has been addressed by the introduction of a new National Estates Information System, which is going to link all 11 or 10 offices. So the paper that we looked at had an extensive literature review, which established 11 themes, and I'm just going to talk briefly about each one of those themes. First one being the benefits of BIM. So there's a lot of information available on the benefits of BIM adoption. It's a catalyst for transparency, better integration, and increased productivity in the sector. It's changing how buildings look, how they function, and how they're managed. It encourages stakeholder engagement and area involvement. One of the major benefits is the productivity and collaboration that it involves, and knowledge sharing and integration between the design professionals is enhanced. It improves communication efficiency, which leads to time saving and more efficient decision making, and provides an opportunity for standardization, which is huge across the health service. Facilitates early production of detailed information, which hopefully reduces changes. And there's an explosion in off-site construction, which is great because it's less time on site, reducing costs and improving health and safety. So those are some of the benefits. There are numerous other benefits as well, some included here. Healthcare specifically. At the center of healthcare, the aim of our buildings is to improve patient outcomes, provide an environment to reduce stress, and allow healthcare professionals to do their job safely. So we know that healthcare buildings are technically complex. They're highly serviced buildings with high regulatory demands, a lot of standards and regulations to be required. Infection control is key within both construction and during the operational phase for obvious reasons. Health sees continuing change in technologies and medication and diagnostics, etc. So that leads a need to continually change and improve our buildings. And we have an informed, competent, and diverse range of stakeholders, all of who need to be listened to, and sometimes can be very vocal in their requirements. Onto visualization, and whilst they are vocal, end users in a lot of cases are very focused on their job in healthcare and have limited ability to read 2D drawings. So the ability to communicate design is critically important. None more so than at feasibility, where visual creation is very important to let these people know what we're building, where, what it's going to look like, and how it affects them and the patient. It's also critical to be able to visualize phasing and understand the impact of construction work in live hospitals on existing facilities. So the National Children's Hospital is a good example where the visualization was used, Google Cardboard, to visualize theaters before design started. It was a key tool for planning approval, and it's also used to consider visual impact on the surrounding areas. I have an example here of two room data sheets, which I've just presented. The top one is in 2D, and the bottom one is using 3D in the last 4 or 5 years. It's very representative because it actually represents the consultation that was involved, and you can see the 2D version, there was hardly any comments, and we think that's probably because the users didn't simply understand the drawing, where you can see in the bottom drawing much more engaged and much more involved in the design process. So the ability to do consultations in 3D reduces the consultation time, minimizes reworks, and saves money. Policy is a large area that we need to discuss. So the public sector bodies and governments around the world have been mandated BIM to address decline in productivity. The EU BIM Task Handbook was launched in 2017, and this provides a common approach for BIM's introduction to the public sector organizations within Europe. Also in 2017, in the Action Plan for Jobs, the government included a requirement for the Office of Government Procurement and Enterprise Ireland to prepare a strategy for BIM adoption in Ireland for the capital programme. The OGP responded to that with a position paper which set targets for BIM adoption on public projects ranging from 12 to 48 months. And in December 2018, the National BIM Council launched the roadmap to digital construction with 4 pillars of leadership, standards, education, and procurement, and set a certain amount of targets. The construction sector group has been set up by government to ensure the construction sector is well positioned to deliver on the commitments of Project Ireland 2040. So the Irish construction industry is adequately positioned to respond to BIM mandate. The Education Centre has responded very well to the need for training and appropriate academic qualifications. And the architecture is largely in place with the ISO standards, templates, and the roadmap. There are, however, some chronic barriers, including lack of funding, low client demand, and the absence of suitable contractual frameworks. And at this stage, I have to acknowledge that CETA have been advocating the use of ICT and BIM since 2011. And published numerous papers on the state of BIM. Education and training. Education is one of the pillars of the MBC roadmap, and the Irish Education Centre ranks amongst the best in the world for the adoption of its programme for construction-related BIM. BIM maturity is supported by training and education, and education institutions are key partners to have responded rapidly to the industry requirements. And the CETA BIM Innovation Capability Programme outlines the education response and the available programs around the world. So what does this mean for public sector? The public sector requires significant upskilling. Education is key for all government representatives. Staff need to be upskilled in software and, more importantly, the processes. Focus should be on client requirements, and education and training will empower BIM-ready staff to take up leadership roles. So the technology that we have and what today and in the next couple of days is so much all about, many teams struggle with new technology, but at least the industry now is embracing BIM. And there are numerous technology available. I'm not going to go into them today, other than to say I've left half of the slide blank, because even as I'm speaking, there's probably new technologies released that will advance us further. The client role is very important with 4 key aspects to consider: information, leadership, expectations, and commitment. I'm not going to go into the detail on those, but they'll be available in the slides after for anyone that wants to read up on it. The industry is very important, and the construction industry is one of the last large industries to significantly embrace technology and its opportunities because of poor collaboration within the supply chain, outdated regulatory and practices and monitoring. It's often fragmented and polluted with duplication, and there's a difficulty recruiting and retaining diverse talent. So foreign direct investment companies were a big catalyst for upscaling contractors in Ireland in the early 2010s. Public work contracts became the lifeline of contractors post-recession, despite their problems. However, there's still an inconsistency across all projects, and this needs to be resolved. The sector is full of adversity between members. Information is closely guarded and seen as power. The confrontational behavior must change, and the collaborative processes and policies must improve. So this means that BIM is now the centerpiece of the construction industry's digitalization, and the government and industry must work together to embrace the change. The public works contracts, the capital works management framework was introduced in 2007 with stated aims of greater cost certainty, better value for money, and more efficient project delivery. They've been mired in some problems with the oppressive environments for struggling contractors and the transfer risk not really being as it was originally intended. And as stated before, information is power, so the risk doesn't transfer as intended. The current forms of contract don't support collaboration. The design teams are experiencing duplication of work as the BIM implementation is overlaid on traditional programs and targets. Clear protocols are required about who is responsible for what and how to allow design teams to price it accordingly. And work is required to amend the suite of existing contracts to incorporate at least a BIM amendment. So implementation and information management. So we know that BIM is building information modeling, but as important for the health service, it's better information management, which leads to better integration of project teams, better collaboration, better communication, and better coordination. But the implementation of BIM can't just be about the software, it must be about the technologies, the people, and as important, the process around the BIM processes. There are numerous restrictions and barriers, of which we've heard a lot of previously, some of which are cost, the technology, and the education, which are hopefully being addressed. So we have recently, as I said at the start, engaged with the new National Estates Information System, which we've done by configuring with our colleagues, our partners, sorry, in Oracle Aconex, who we will be using for our common data environment going forward. We've engaged with our users, and their hopes is that implementation will provide standardization of work, a consistent approach, enhanced cohesion and compliance with our protocols, greater efficiencies, and better visibility. And we've got to the stage where our configuration is more or less complete, and we're about to start rollout by pilot projects, which we will then consistently review and improve our processes. The strengths of our existing team have been identified to enable the digital transformation, including that we've got a very digital literate team with good experience, with a good work ethic, and well structured. We've also identified a number of issues to make implementation a success, of which training, communication, and help desks, and we will have a help desk set up, which is key in that. So as part of our NES engagement, we're discussing with all our partners, construction industry, and other public bodies, and we have recently set up a National Estates BIM working group. So in conclusion, there are numerous benefits to implementing BIM within the HSE: productivity, standardization, collaboration, knowledge sharing, and better decision making are key and align with our requirements in NEIS. There are also a number of challenges, including the fragmented nature of the industry and risk transfer, etc. But on balance, we think the battle has been won, and it's been helped with the introduction of the new ISO standards, the National BIM Roadmap, and the fairly extensive education and training. There's still a way to go, which we need to be able to tip the balance more by invested clients, the public sector leading more in the BIM revolution, revised contracts, and more funding and training made available. So in conclusion, the HSE, with the rollout of our NEIS system and BIM, are in a good position because we have got focused leadership with good structure in place, professional and knowledgeable staff who are digital literate, ready to embrace technology, have great technical ability, and are used to delivering change. So that all positions the HSE very well to become leaders in the public sector digital transformation. And the full paper is available in the conference proceedings. Thank you.
Okay, thanks, Michael. Very interesting, and again, it just reinforces the point that I suppose the public sector in every country around the world is the biggest construction client, and certainly the health HSE in Ireland has a key role to play. So it's great to see that research and your own role in all of that. Lots of big ideas. I think you pointed out a lot of the challenges, but I think we have made great strides. But that's not to say we shouldn't shy away from those challenges. And again, CETA is playing a key role. I think you also mentioned the construction sector group, which is a very important group that's come together, and then the work of that in the next couple of years should be really important. So at this stage, I'm going to move to questions and answers. Well, questions anyway. Hopefully, we'll have some answers from Conor, from Zulkefly, and from Michael. Actually, the first question coming up here probably relates to you, Michael. Well, there's a comment about contacts in the UK. In terms of your own journey in the HSE in Ireland, have you had international contacts? And secondly, are you aware of any policy changes within the HSE forcing contractors, designers, and others to use BIM?
Yeah, well, I suppose, Ken, we're at a very early stage, believe it or not, in our journey. I mean, mostly we've been driven by our design partners in the last number of years who've been kind of started using BIM to advance the designs. And it's probably true to say we've come a bit late to the party, but we're now getting mobilized, as is probably all of the public sector across the country. But yes, there is a policy shift. I mean, our senior management team have recognized the importance of BIM, and we've set up the BIM working group. We're probably going to be engaging a BIM consultant to talk about our national policy on standards and direction for the HSE going forward. But we definitely want to be one of the leaders in Ireland to be able to push the whole public sector digital journey.
Yeah, I mean, there's obviously a carrot and stick approach to BIM, and we found that a lot in CETA. Government in all its forms could be the big stick and force a lot of the contracts down this road. But obviously, we're trying to encourage people to go this way for good reason, and it's more efficient and a better industry for everybody. So it's kind of a two-way approach. You also mentioned the education. I'm very aware, obviously, from a home point of view, but definitely that's a huge bottom-up approach as well. And all our graduates should be coming out of our universities with the skill sets and the knowledge to push the boundaries. I'm sure it's happening in UCD with Conor there and others as well. So that's good to know. Yeah,
I mean, as far as the HSE is concerned, we're absolutely committed to it. And even, I mean, my own journey in the last year seen me taking the degree in TU Dublin. And I know even as we're getting through our National Estates Information Committee, a number of other colleagues have recognized the benefit already and are now enrolled in the next course for the same one. It's also true to say that, you know, small steps breed large ones, because we can already see engagement from our hospital colleagues or nurses and doctors when they can see the visibility aspects of, you know, the very simple stuff that BIM can bring. Just being able to, you know, visualize what a room looks like, where the equipment's going to be. That has even, you know, revolutionized the amount of time that it takes us to get through the design stages of projects.
Yeah, I think you're right. I think once people see what's the potential of a lot of these technologies, they buy into it quite quickly. And again, I would make the point again, we talk a lot about comparing ourselves to Denmark. Somebody mentioned about a BIM mandate. Denmark went that way in 2007, 14 years ago. Now we are a very similar population, lots of similarities. We learn a lot of lessons from Denmark. But I think we're of a size as a country where we're sort of, we're, you know, a good size, but not too big in the sense that we can make changes quite quickly across our various sectors within the overall industry. And I think I would remain optimistic. I might move to Conor. Conor, if you don't mind, from your perspective, I know you mentioned the facility management example of Schiphol and whatever, but could you see the semantic web coming to the health arena and how that might be used, where the advantages might be in that area?
Definitely, yeah. I mean, I think one of the things I was discussing with a colleague ahead of the talk today, and when I said about it being, I think, capable of a paradigm shift, she made a good point, was that this isn't a kind of technology on the hype cycle that's maybe going to go back down again. Semantic web is used, and semantic web technologies are used in many industries. So construction it's not something specific to construction. And actually, I showed the open web of knowledge earlier. A lot of that is healthcare related ontologies. And so, yeah, it's definitely being used in the healthcare domain. I suppose it's really a similar situation. A hospital is one of the most complex pieces of infrastructure we have. So the power of ontologies to automatically structure information and answers and generate reason and new knowledge. Yeah, it's definitely a use that it's doing already, I would say.
Yeah, I mean, whatever sector we're talking about, obviously, the greater clarity and common understanding we have of all of those terminologies will help us all hopefully be a bit more efficient and better and dynamic in what we do. So I think your work is very important. The fact you're tied into an international group is great as well, because I think obviously South Street, from an Irish perspective, we need to learn lessons from everybody abroad. So I think that international dimension is hugely important to your research work and everything you're doing there. So thanks again for that. I might just move to Zulkefly and just ask about, we mentioned blockchain technologies. That was one of the very hyped technologies in recent times, but I'm not directly aware of any particular adoption or use of blockchain in construction at the moment. Zulkefly, would you be aware of any particular examples for our audience today?
I think it's probably from the management side of supply chain, that we can see how we can control and transport data, information of shipping, or maybe from the supply chain sides. In terms of from construction, haven't seen any use case currently available.
I'm not an expert in blockchain, but Conor referred to the getting away from file exchanges and dynamic sharing of data and so on. Is that possible with blockchain? Is that where we're going with some of those technology, with that technology?
Yeah, blockchain is actually focused on a transaction. Actually, how do you record the transaction? If we can see like microtransaction, especially with BIM, when you do like BIM coordination, when you exchange information of solution information, and how you record that information currently is very, very, very broad. Maybe it's very difficult to verify. So probably by introduce a blockchain, you can easily record all the issues within the collaboration or the model itself into a ledger, into a more structured data information, and using a smart contract to actually automation of the information creation and store in a blockchain or off chain, you can say, in a SQL manner, in establish a like relation SQL database within the blockchain itself.
Okay, thank you for that. Conor, just come back to you. I touched on, I think you mentioned digital twin. Again, it's a thing it's a big topic. I know there's a national digital twin project going on in the UK at the moment. And even from Michael's perspective, if we had a digital twin of every hospital or every HSE in the country, would that be a good thing? I suspect it would, even just the physical, there's a static version of all our, knowing where everything is and being able to visualize it and see it in a digital form as well as in a real form. But in terms of ontologies, you mentioned the fact that getting to that, the work you're doing might be a quicker way to get to help with some of that knowledge exchange. Am I wrong, or did you mention that in your presentation?
Yeah, no, that's about right. I suppose what I'm interested in is the scalability of these things. And you know, we can do digital twin. There's companies will do it for you. That's very, very expensive and costly to implement. O&M for a building and have a live you know, sensor feed of your building, it's very costly. So there's no question it can be done. I think that's the point of academia, is to try and make it more accessible, make it possibly cheaper. And I think well, we see it's a real paradigm shifter in that it relies much more on being open with data, and that's really complex in construction. You know, for example, I gave the Schiphol example there, where they're having all of their FM contracts using open data, and really interesting talk. I do encourage anyone to have a look at that link. But one of the main reasons they're doing that is to get away from situations of vendor lock-in, where you know, we continue down a road with a vendor just because they've been doing it for that long. So, you know, in construction industry, we're stuck with a lot of, let's say, legacy structures. So, for example, BIM data is really, really complex. So I'd say like the big challenges for getting open data, getting semantic web technologies working is trying to get those very complex BIM structures into a format that's efficient. And that's not always the responsibility of academia to tackle efficiency and cost. It's more proofs and proofs of concept. So, but yeah, it's really interesting. We're a group of people from across the world, but all kind of looking at that. What can the cloud do? What could it do? How could it change things? And I think, just like Zulkefly was saying, we're just imagining how it could be better. You know, I've worked with building information modeling about 10, 12 years, and you know, you're the gatekeeper. If you're the BIM guy, you're the BIM girl, you're the gatekeeper, and people give you data to put into a BIM model, and that's not right. You know, we're all used to using collaborative Google documents at this point. You know, things should be a lot more easy to contribute and easy to query. And that's what the cloud allows. It allows to access data, not to exchange data. So yeah, it's just thinking how things could be a bit different. And we have a long way to go, but we think it's part of the solution, at least.
That's good. I mean, I like the philosophy of open source and easier and faster and all of that, but making it happen, obviously, as you know, is a challenge. And again, it was touched on by Michael in particular. Even Michael, I just finished with you, Michael. We're coming towards the end of the Q&A. You mentioned there about the new National Estates Information System, which you're trying to align with. How easy is it to get everybody to share their data in that sort of situation and in formats that is easier to move around, certainly within the HSE?
Sorry, I muted myself there. Yeah, obviously in the HSE, we're talking about, I mean, we talked about 4,000 blocks of property there, so it's very difficult to sort of get everybody in the same wavelength. But I thought it was very interesting what Conor was saying there about academia and pushing forward with all of the, you know, the technologies and trying to make the BIM technologies better. We're coming at it almost from the very other end, where we're starting on our BIM journey, and we need to get people aligned to the benefits of sharing information. I mean, our National Estates Information System is just that. It's a common data environment, and it's a single source of truth. So at the minute, we've got 11 offices, and you know, you have to go and either meet somebody or ring somebody up to say, you know, where's that project at, or, you know, how much have you spent there, or whatever. We're now at the stage where we can collate all that information together, and anyone can see, you know, the most up-to-date information, which is critical in healthcare, because, I mean, you know, we've any number of hospitals around the country, and we should standardize them all as best we can. So we should be able to get learning from the hospital in Cork or the hospital in Donegal, so that we know when we're building a hospital in Galway what the good things and bad things were. So that's the opportunity that has been opened up by our Estates Information System. It's the ability to share, collaborate, and more importantly, standardize. And I mean, we've already mentioned our partners Oracle, who are rolling out the Econex system. We've already used the new ISO 19650 annex to set up the naming convention for that. So, you know, we're slowly moving in the direction of standardization. I think that can only be a good thing.
Okay, Michael, that's great, and I think we're kind of coming up toward the end of our Q&A session here. So, as chair, I'm going to bring it to a close just by saying, first of all, thank you to Conor, to Zulkefly, and Michael for very thought-provoking and very good presentations. Thank you so much to everybody, and be very open with your answers as well to the various questions that were pitched at you. We really appreciate your involvement, and again, hopefully people will ask further questions after this event, and maybe generate new contacts and new ideas, which Conor referred to earlier on. Is always thinking it aloud or thinking differently is always a good idea. So again, I'm just going to finish as well by thanking Yelenia and Elaine for all the help with this session, and indeed Alan, Suzanne, and all the great work of the CETA team in the background. CETA played a really key important role in moving this agenda forward over the last 20 years, and we hope to continue in the future, obviously aligned to all the other initiatives and projects that are going on, in particular the construction sector group. So thanks again to everybody, and hopefully we'll see you at the next session. Thank you. Bye-bye.